Morning, everyone. This group project will presented by our group, which is number 10. The title of the group project is about windowing filter, which has many filter. The member of the group is me, Kwatekpo, Kwatekwa, Chimfulin, Muhammad Farid Haikal bin Muhammad Rosli, and Muhammad Danish bin Ahmad Ramli. So for first, we need to know about what is window filter. Window filters are essential tools in signal processing, image analysis, and data science. They apply a mathematical function over a specific range or named as windows to process data by reducing noise, smoothing signals, and enhancing features. Their primary purpose is to minimize artifacts like spectral leaking and improve the accuracy of analysis in both time and frequency domain. We can also compare this time domain and frequency domain to see which filter is the better for signal processing. So the window filter also have many types, which is Kaiser filter, Hans filter, Hamming filter, Bartlett filter, and rectangular filter. And there are also many filter in signal processing. So for our project, we choose two window filter, which is one of it is rectangular filter. So the rectangular window filter is the simplest type of window functions. It applies equal weighting to all data points within the windows and abruptly drops to zero outside it. While it computationally efficient, its sharp edge cause significant spectral leakage, which is limiting its performance in application requiring high accuracy in frequency domain analysis. For the second window filter is about Bartlett window filter. The Bartlett windows, which is called as triangular window, that improves upon the rectangular filters by tapering linearly to zero at the edge. So if you smooth transition, reduce spectral leakage, and offers a balance between resolution and suppression of side loops. It is also commonly used in spectral analysis, speech processing, and FIR filter design to enhance signal clarity and reduce noise. So this is about the filter. So we will proceed to the second, which is methodology.
Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about the methodology. So we have three parts of method. That is, the first one is the research approach. The second one is the tools and the materials, and the third one is the implementation process. So for the first one is the research of approach. Is the objective of this project is about to compare the performance of the rectangular and the bartlett windows in signal processing. So for the analysis, for the domain of analysis, is we have two domain. So the first one is the time domain. It is about the visualization of the window shapes, and the second is the frequency domain, that is evaluation of the spectral characteristics. That is three. You have three is the main lobe, side lobes, and the leakage. So the key of this, what is the key matrix about the performance of the assessment based on the frequency resolution and the spectral leakage separation. So the second one is the about the tools and the materials we using for this project is we using the MATLAB software. So the function used about it we use function is about the rectwin is the rectangular window and the bartlett is the bartlett window. So for the second one is the analysis tools. We have we use is the FFT, that is the fast Fourier transform, and the frequency response calculation is in decibels dB. So for the parameters we have two. For the window length is about the 64 samples, and the zero padded FFT length is 1024. Lastly is about the implementation process. So what is implementation? What is implementation process is we have the window creation. So for the window creation, we generate the rectangular and the bullet windows in the MATLAB software. So we can see that we visualize the shapes in the time domain. So the second one is the frequency analysis. So we compute and normalize the FFT for each window, and we convert the frequency responses to the decibels. So lastly is about the comparison. So we have two. That is the first one is the assess the frequency resolution, that is window load width, and the last one is we evaluate the spectral leakage, that is side lobes levels. So that's all from me. Thank you.
So I'm Pratikwa. Then to present about the result. So first we use the number of point, which is number of sample, which is 25. Then we will use the function red, win, and palette to generate the rectangular window and palette window. So these two is rectangular window and the palette window. After that, we will plot it in the time domain is using subplot and plot. This plot is plot the rectangular window in blue color and the line width is 1.5. The second one is the palette window, which in red color and the line width is 1.5 also. So then we compute the rectangular window signal and the palette window signal to the fast Fourier transform using the FFT and change it to the magnitude using the ABS with the length is 1024. So the frequency length is we use negative 0.5 to 0.5. Then we use the support
and plot the frequency response graph using plot. This is the frequency, which axis is frequency, and then this one is the formula for the magnitude in dB. So it's 20 log 10, and then the rectangular uh, length, rectangular window length in frequency response per the maximum, the highest magnitude in the rectangular window in frequency response. So in blue color, and the line width is 1.5. Same with the barrel window. So we will get these two graphs. So the rectangular window, uh, it has narrow width, which is here to here, and so it's narrow. So this will enhance the frequency resolution. I- With this, it will make it more easy or more effective to distinguish closely spaced frequency. Then the pilot window has wider the width, the main loop width. So this will limit the pilot window to resolve closely spaced frequency, and hence this will also decrease the frequency resolution. So for the side loop, the rectangular window is less effective for isolating signal because the side lobe is higher comparing to the pilot window. So the side lobe is negative 30 dB, while the pilot window is approximate 25. So for the high side lobe, so it will less effective for isolating signal. For low side lobe, so it can minimize the unwanted interference from outside signal from the main beam.
Hi, I'm Chevrolet. I'll present about the discussion of this project. The rectangular window and barrel window, or as known as triangular window, have different characteristics. This makes them suitable for different applications. For figure at right, we can observe that the barrel window in orange color, it suppresses the side loop until about 26.5 dB below the 0 dB. While rectangular window is only suppressed about 13 dB. The lower suppression of the side lobe make the rectangular window less effective at isolating signal compared to barrel window. For the wave of main lobe, rectangular window is about 15 Hz. Is narrower than 31 Hz of the barrel window. A narrow window makes rectangular window more effectively for distinguish closely spaced frequency between two different signals, while wider main loop make pilot window more useful when smoothen the spectrum. For frequency resolution, rectangular window is higher than the pilot window. In other words, rectangular window has a lower dynamic range compared to pilot window. This means that rectangular window have a clearer output after windowed, while barrel window is good at processing the disparate amplitude. For ringing effect, rectangular window cause a lot of ringing effect because sharp edge of the window and form Gibbs phenomena. Bartlett windows have a smooth triangular shape. In transition, it will have lower oscillation, a clearer and more stable output in frequency response. For the application of the rectangular window, due to the narrower main lobe, higher resolution, and lower scale loss, rectangular windows suitable to windowing transient signal such as burst or impulse to use for analyze. Refer to the figure at, in the slide. An additive composite signal acts as signal produced when machine switch on is the first composite signal, and the second signal response is windowed by rectangular window, while third signal is third signal response is windowed by Bartlett's window. The amplitude of spike does not change at second signal response, but lower down at the edge of the third signal response. This causes signal-noise ratio of the signal degrade and not suitable for analyzing more. For Bartlett window, lasering effect and higher dynamic range compared to the rectangular window make Bartlett window used to smoothing a signal. Refer to the figure in slide. The top signal acts as the signal need to be smooth, while second and third are the signal response after smooth by using convolution with Bartlett signal in different size and rescue after window. By observe the second and third signal response, the smoothing effect increase when the size of the Bartlett window increase, but the too large size of the window will get the signal lose its characteristics.
Assalamualaikum warahmatullahi wabarakatuh. Now I'm going to present for the conclusion. In this assignment, our group analyze and compare the characteristic of the rectangular and bartlett windows in the digital signal processing. These window techniques are integral to the filter design, spectral analysis, and other applications where frequency resolution and side lobe suppression are critical. Through this study, we observe that each window type offers unique advantages and limitations, making them suitable for different signal processing tasks. For the rectangular windows, it's characterized by the sharp transition and the uniform weighting, provides superior frequency resolution due to its narrower main lobe. However, it have a high lobe level, high side lobe levels, leads to a significant spectral leakage, which can obscure weak frequency component in a noisy environment. On the other hand, the Bartlett window have a taper edge. It offers better side lobe suppression and higher dynamic range, making it more effective in reducing spectral artifacts and identifying weak signal, but at the cost of slightly reduced frequency resolution. The experimental result confirmed this insight. Frequency domain analysis revealed the rectangular window propensity for the ringing effect is a consequence of the Gibbs phenomenon, while the smoother transition of the bartlett window reduced this oscillation, delivering a more stable frequency response. This makes the bartlett window particularly advantageous in applications like sound processing and noise reduction, where the clarity and stability are paramount. Uh, for the MATLAB simulation, it also demonstrates the practical implication of this window in a real-life scenario, such as filtering noisy signal. While the rectangular windows allow for better separation of closely spaced frequencies, the bartlett window provides a clean spectral representation by minimalizing high-frequency interference. So the choice between the rectangular and bartlett windows depends on the specific requirement of the application. The rectangular window is preferably when the frequency resolution is a much more higher priority, whereas the bartlett window excels in scenarios demanding better side load suppression and reduced spectral leakage. By understanding the trade-off between these windows, uh, the they can select the most appropriate technique to optimize performance in their respective digital signal tasks. That's all from me. Thank you.